So in this video, we're going to talk about cross product and it. So given two non-zero vectors, which is a3, and b equal to b2 and b3. Now, it is very useful to be able to find the non-zero vector that is perpendicular to both a and b. Now, if c, which is equal to c2 and c3, is such a vector, then ac is equal to 0 and b dot c should also equal to 0. So a1 c1 plus c2 a2 plus a3 c3 should be 0. So let me name this equation as equation 1. Another equation is b1 c1 plus b2 c2 plus b3 c3 should also be equal to 0. I'll name this equation as equation 2. To eliminate c3, just multiply equation 1 by b3 and 2 and equation 2 by a3, and we subtract. So when we are done multiplying, then we subtract. So just take note of these statements. Now, so let's go ahead and eliminate them. So with that, we are going to have, let me use different color here. So with that, we are going to have a minus a3 b2 multiply c2, which is equal to 0. Now, equation, so this one is in the form of pc1 plus qc2, which is equal to 0. So we have p representing a1 b3 minus a3 b1. So the q here is negative, so which is the a2 b3 minus a2, right? Now, so when we are done with that, we just have to substitute them. So with that, we have c1 being equal to a3 b1 minus a1 b3, right? So substituting this equation 1 and equation 2, we then get c3 here to be a1 b2 minus a2 b1. So this means that the vector is perpendicular to both a and b, which is c1, so this one is in bracket, c2 c3 is equal to b3 a1 b2 a3 b1. So this is what we get. Now, the resulting vector is called the cross product of a and b and is denoted by a times b. Is a cross product. Very simple. Now let's go to the next page. We are going to define something, so just pay attention to that. Now, if we have a which is equal to b2, a and b is the vector a times b equal to a1 b2 minus a2 b1. The cross product of a and b, unlike the dot product, is a vector. So for this reason, it is also called the vector product. Also note that a times b is defined only when they are three-dimensional vectors. So in order to make the definition that I said we are going to do, so this is my definition 1. So in order to make definition 1 more easier to remember, we use the notation of determinants. So a determinant of 2, so a determinant of order 2 is defined by, so with that we are going to have a b c d. So a takes d, so we are going to have a d minus bc. That's a determinant of order 2. Now let's take an example with the real numbers. So let's say we have, for example, if we have 2 1 negative 6 times 1, so 8 minus 6, and we have 8 plus 6, which is 14. So let's look at the determinant of order 3. So let me go to the next page here and use red color. So a determinant of order 3. How do we do that? So let's say we have a1 a3 b3 c1 c2 c3. How do we find a determinant of this? With this one, we're going to assign some signs to it. So we have this negative sign, this positive sign. So with a1, then so under a2 we have b2 c2. We don't take that. And with the column side we have c3 b3 of 1 b2 equal 5, right? So we can rewrite the 1 using the basis vector, which is, so we have the standard basis vector.